Hello everyone, welcome back to JD Science Prep. Today we are going to be talking about refraction calculations. So similar to calculating in our reflection section, we have a few different equations that we can use. The first one here is the thin lens equation, so we just have 1 over f equals 1 over di plus 1 over do, where f is our focal length, di will be the distance of the image, and finally do is the distance of the object. And over on the right side here we have the two magnification equations. We have m equals hi over ho, and on the right side here we have m equals negative di over do. Just quickly here, m is for magnification, hi is the height of the image, and ho is the height of the object. So let's take a look at a few notes here before we go over a couple examples. First off, we have virtual image distances will always have negative values. Real image distances will have positive values. Positive magnification and image heights will result in a upright image. Negative magnification and image heights will result in a inverted image. And finally, the last little point here, diverging or concave lenses, they're the same thing, will always have a negative focal length and di, or distance of image. Okay, so with that in mind, let's go over a couple of examples here. Number one, I'll just zoom in a little bit, make it more clear for us. It says an object that is 6.0 centimeters high is placed 22 centimeters in front of a converging lens. I'm going to just underline that for later. With a focal length of 15 centimeters, what is the location and height of the image? So first off, let's just write down exactly what we know from the question here. We have our height of object. So our height of object is 6.0 centimeters, and it's placed 22 centimeters in front of a converging lens. So our distance of our object from our lens is 22.0 centimeters. And finally, our focal length is also given to us. It is 15.0 centimeters. So first off, we are figuring out the location and height of the image. So let's do the location first. We're going to be looking for di. Okay. So remember, we have 1 over f equals 1 over di plus 1 over do. And if we manipulate that, we can just subtract 1 over do from both sides here. And we'll have 1 over f subtract 1 over do equals our 1 over di. And let's just fill that in now. So we have 1 over the focal length, which is 15 centimeters, subtract 1 over 22 centimeters. And let's just type that into our calculator really quick here, folks. We have 1 over 15 subtract 1 over 22. That'll give you a decimal, so 0.02121 repeating. And if we take that, so 1 over di is equal to that decimal number, so 0.021 repeating. If we take the reciprocal of that, so basically we are just flip-flopping where di and that decimal number are. If we take the reciprocal of that decimal number, we will get our answer. So just 1 divided by 0.021 repeating. We will get a di of 47 centimeters. Okay, and that's with significant figures. We can only keep 2 here. Maybe let's keep 3. Just because we used numbers with 3 sig figs. So 47, I'm going to erase that 0, 47.1 centimeters, and we can add that to our stash of numbers here. Perfect. And we also have to figure out the height of the image. So to figure out our HI, I'll give you a little hint. We have to figure out our magnification first. And I'm just going to move this stuff down here so we have a little bit more room. Keep it nice and neat. Okay, there we go. That should give us enough room there. Perfect. Okay, so we have a couple different formulas that we can use to figure out magnification. And I'm just going to scroll up and show us. We have m equals hi over ho, and m equals negative di over do. We have di and do, so we can use that one here to figure out our magnification. So we have m equals negative di over do. Let's just fill in exactly what we have here. So m equals negative 47.1 centimeters, and that is over our do, which is 22.0 centimeters. And type that into your calculator, and let's figure out what we have here. And based on our negative di over do formula, we should get a negative magnification here. Let's just make sure that we do. Yep, that makes sense. So our magnification here, folks, if you type in negative 47.1 divided by 22 is negative 2.14, and we have no units there. The centimeters will cross out. And finally, with that, we can figure out the height of image as well now. So I'm just going to add to our stash of numbers. We can figure out our HI now with our other magnification equation. We have m equals hi over ho. We have to manipulate for hi, so we will multiply our ho up. So we should get hi equals magnification multiplied by ho. Let's work up here now. So hi equals our m, which is negative 2.14, multiplied by our ho, which was given to us right here. So it's just 6 centimeters. Awesome. And if you type that into your calculator there, you should get the height of image. So negative 2.14 multiplied by 6.0, and you should get a HI of negative 12.8, and just with significant figures here, we can say negative 13 centimeters. Okay, awesome. So that is example 1 here. A couple key things. Make sure you keep this negative in our first magnification formula, negative di over do. That will influence the rest of your steps here for your magnification and HI. And let's move on to example 2. Example 2 says an object that is 11 centimeters high is placed 16 centimeters in front of a diverging lens with a focal length of 8 centimeters. Find the image location and height once again. So we have an object that is 11.0 centimeters high. So our height of object is given 11.0 centimeters. And we also have our DO. We have our DO given to us, and it's 16.0 centimeters. And we have a diverging lens here, folks. So remember back when we were going over our little hints and notes, whenever we have a diverging lens, our focal length and DI are negative. So this 8.0 centimeters, it is going to be negative 8.0 centimeters. And that should set us up. So first off, we're going to find the image location and height again. So we're looking for DI. to start. So we're going to follow the same process as last question here. We have 1 over f equals 1 over di plus 1 over do. We will manipulate to figure out or isolate our di here. So we'll just subtract 1 over do again. That'll cross out. So we'll get 1 over di equals 1 over f, subtract 1 over do, and we'll just fill in our variables here. So we have 1 over di equals 1 over negative 8.0 centimeters, subtract our 1 over do, which is 16 centimeters, and we'll get some kind of decimal number here for 1 over di. Let's just type it into our calculator really quick. So we have 1 over negative 8, subtract 1 over 16, and you should get negative 0.1875. Let's keep all of our digits here. And again, we're just going to take the reciprocal of that decimal number here. So 1 over negative 0.1875 should be our di. And let's do that really quick. So our di should be negative 5.3 repeating. And we're just going to keep 1, 3 there. And we'll add our units in. So our di is negative 5.3 centimeters. That looks good to me. So let's add that to our stash of questions here, stash of values, and let's move on to finding the image height once again here. So again, we'll have to use both magnification formulas here. So our first one, similar to last question, we have m equals negative di over do, because we have both of those values now, and we can just insert both of those in here. We have negative 5.3 centimeters over our 16 centimeters. I'm just going to scroll down a little bit here so we have more room. And if you type that into your calculator, and just a quick note, make sure you keep both of these negatives, because with two negatives comes a positive, and we need that positive to be 100% correct on this question. So if we type this in correctly into our calculator, we should get a magnification with sig figs of 0.33125. So 0.33, we'll keep 2 sig figs there, and I'll box that off. And finally, we have one more formula to use. It's our other magnification formula. So we have magnification equals hi over ho. Remember, we are finding the image location and height. So we're trying to find the height right now. So we're trying to isolate hi. We'll multiply ho up. And just like last question, our manipulated formula will be hi equals magnification multiplied by ho, and we can just fill in those values now. So our m from last question, we have 0.33, and that's multiplied by our ho, which was given to us in the question, which is, I'll just underline it right here, 11.0 centimeters. And type that into your calculator. So 0.33 multiplied by 11.0, and that will give us our hi. So you should get a hi of 3.63 with significant figures. I'm just going to keep 2. So 3.6 centimeters, and notice it is a positive value. I'm just going to make this a little bit neater here. It's a positive value, so that means our image is upright. Okay, so our hi is 3.6 centimeters. That is it for all of our examples. I hope this video has helped.